Water is the dynamic force that continually shapes Rocky Mountain National Park. Transformative processes usually take long periods of time. But some extraordinary events can make drastic landscape changes overnight. I'm Karina Puikkonen with the Continental Divide Research Learning Center. The storm that produced Colorado's 2013 floods also shifted large amounts of sediment in the park. Two groups of geomorphologists have accepted an invitation to help us understand this recurring chapter in Rocky Mountain National Park's natural history. Horseshoe Park is named for the distinct shape Fall River takes as it meanders down this large riparian valley. This area experienced visible changes after steady rain fell for several consecutive days in September 2013. It was the second time Roaring River sent water and sediment thundering down its riverbanks. An unnatural dam breach on Long Lake in 1982 initially scoured this river channel and created the alluvial fan. During the relentless 2013 storm, the second round of flooding redistributed sediment across the alluvial fan and changed how sediment is delivered to Fall River. No one was more surprised than Dr. John Pitlick from the University of Colorado Boulder. He first studied sediment transport in the 1980s after the Long Lake flood.
The Rockies are made up of crystalline rock. It's old crystalline rock. It's fairly resistant to erosion, and so in general, sediment supply to these rivers is pretty low. The difference here is that Roaring River, because of the instability caused by these two floods, is a pretty good sediment producer at this point in time. And so it's a unique opportunity to look at the dynamics of a river system that is carrying many orders of magnitude more sediment than it normally would.
Dr. Pitlick's new project tracks how the sediment now moves through Fall River. His field crew gathered current data about flow rates and sediment loads in the stream bed. This new information, along with the original 1980s dataset, can help predict the future evolution of these river corridors. Horseshoe Park wasn't the only place where massive amounts of sediment moved. Multiple debris flows are also easily visible along the eastern boundary of the national park. Dr. Sarah Rathburn of Colorado State University is especially interested in the Bighorn Creek slide near the Fall River entrance station. She discovered older deposits underneath the new slide that posed many questions.
What are the upland processes that control debris flows? Why did they occur? Was it really just an anomalous because of a freak storm? Or are there some other reasons because of hill slope angle or aspect, maybe depth to bedrock, some other controls that might have areas that might allow the park to target areas that are sensitive or more prone to future debris flows?
Dr. Rathburn's team is studying these older layers to understand the physical conditions of previous slides. They'll also date debris flow scars on trees and rocks using techniques such as dendrochronology and lichenometry. While the landslide scars will be visible for years, Dr. Rathburn is collecting relevant data before this information erodes away. Land-shifting events that happened during the September 2013 floods remind us that change will always be part of the processes that form this distinct scenery. Understanding how and why physical changes occur will help us better prepare for the future of Rocky Mountain National Park.